Listen to part of a conversation between a student and her biology professor. So, the assignment is to reproduce one of the animal camouflage experiments we read about in our textbook. Which experiment did you pick?
Well, I was wondering if I could try to reproduce an experiment that's kind of the opposite of what was discussed in the textbook.
So, instead of how and why an animal might hide itself, you want to do something about why an animal might want to be seen? Tell me more.
Well, I got the idea from one of the journals you said we should look at. It's an experiment about, they called them eye spots in the article.
Eye spots, sure. The patterns on the wings of moths and butterflies that are generally believed to scare off predators because they look like big eyes.
Yeah, except the article was about an experiment that disputes that theory.
Well, we know that the markings do scare the birds, but the idea that the spots look like eyes is, well, that's just a commonly held belief.
So that's not even based on research?
Well, this whole idea of moth or butterfly markings being scary because they look like eyes rests on how we imagine that their predators, like birds, perceive the markings. And we can never really know that. All we can do is observe bird behavior. But tell me more about the experiment.
Okay, so the experiment looked at the shapes of the markings on moth wings. The researchers wanted to know if the markings that were round or eye-shaped were more effective at deterring predators than square or rectangular markings.
Okay.
Yeah, so they attached food to paper models of moths with different shaped marks drawn on the wings to see how birds reacted. And what's interesting is they realized that the round marks were not more effective at scaring birds than other shapes.
Were they less effective?
No, they were about the same. But what researchers did determine is that larger markings are more effective than smaller markings at scaring off prey. They called this phenomenon visual loudness.
Visual loudness, huh? Well, I guess it's not all that shocking if you think about it.
So anyway, is it okay? Can I repeat this experiment and write about it?
Yes, I think that'll work. The problem I foresee is, well, where? This is an urban campus. You'll have a hard time finding a good place to set up the experiment.
Oh, I wasn't planning on doing it on campus. I'm going home for spring break and my family lives in the country, far from the nearest city. I can set it up in the backyard.
Good idea. Except 1 week is not a lot of time, so you'll need to make some adjustments to have enough data. I'd set up the experiment near a bird feeder and get in as much observation time as you can. Why does the student talk with the professor? What does the professor say is a common assumption about certain markings on butterfly and moth wings? What were the results of the experiment that the student describes? Why does the professor mention a bird feeder?
Listen again to part of the conversation, then answer the question.
The idea that the spots look like eyes is, well, that's just a commonly held belief.
So that's not even based on research?
What can be inferred about the student when she says this?
So that's not even based on research?
Listen to part of a lecture in a botany class.
So, continuing with crop domestication and corn, or maize as it's often called. Obviously, it's one of the world's most important crops today. It's such a big part of the diet in so many countries, and it's got so many different uses that it's hard to imagine a world without it. But because it doesn't grow naturally, without human cultivation, and because there's no obvious wild relative of maize, for the longest time, researchers weren't able to find any clear link between maize and other living plants. And that's made it hard for them to trace the history of maize. Now, scientific theories about the origins of maize first started coming out in the 1930s. One involved a plant called teosinte. Teosinte is a tall grass that grows wild in certain parts of Mexico and Guatemala. When researchers first started looking at wild teosinte plants, they thought there was a chance that the two plants, maize and teosinte, were related. The young wild teosinte plant looks a lot like the corn plant, and the plants continue to resemble each other, at least superficially, even when they're developed. But when the scientists examined the fruits of the two plants, it was a different story. When you look at ripe corn, you see row upon row of juicy kernels, all those tiny little yellow squares that people eat. Fully grown teosinte, on the other hand, has a skinny stalk that holds only a dozen or so kernels behind a hard, almost stone-like casing. In fact, based on the appearance of its fruit, teosinte was initially considered to be a closer relative to rice than to maize. But there was one geneticist named George Beadle who didn't give up so easily on the idea that teosinte might be, well, the parent of corn. While still a student in the 1930s, Beadle actually found that the two plants had very similar chromosomes, very similar genetic information. In fact, he was even able to make fertile hybrids between the two plants. In hybridization, you remember, the genes of two species of plants are mixed to produce a new third plant, a hybrid. And if this offspring, this hybrid, is fertile, then that suggests that the two species are closely related genetically. This new hybrid plant looked like an intermediate right between maize and teosinte. So Beadle concluded that maize must have been developed over many years, that it is a domesticated form of teosinte. Many experts in the scientific community, however, remained unconvinced by his conclusions. They believed that with so many apparent differences between the two plants, it would have been unlikely that prehistoric peoples could have domesticated maize from teosinte. I mean, when you think about it, these people lived in small groups, and they had to be on the move constantly as the seasons changed. So for them to selectively breed, to have the patience to be able to pick out just the right plants, and gradually, over generations, separate out the durable, nutritious maize plant from the brittle teosinte that easily broke apart, it's a pretty impressive feat, and you can easily see why so many experts would have been skeptical. But as it turns out, Beadle found even more evidence for his theory when he continued his experiments, producing new hybrids to investigate the genetic relationship between teosinte and maize. Through these successive experiments, he calculated that only about 5 specific genes were responsible for the main differences between teosinte and maize. The plants were otherwise surprisingly similar genetically. And more recently, botanists have used modern DNA testing to scan plant samples collected from throughout the Western Hemisphere. This has allowed them to pinpoint where the domestication of maize most likely took place, and their research took them to a particular river valley in southern Mexico. They've also been able to estimate that the domestication of maize most likely occurred about 9,000 years ago, and subsequent archaeological digs have confirmed this estimate. In one site, archaeologists uncovered a set of tools that were nearly 9,000 years old, and these tools were covered with a dusty residue, a residue of maize, as it turns out, thus making them the oldest physical evidence of maize that we've found so far.
What is the lecture mainly about? What evidence seemed to indicate that maize and teosinte are not related? Why does the professor discuss hybrids? What was most researchers' initial view of George Beadle's theory about teosinte? What did Beadle conclude about maize and teosinte? According to the professor, why was the discovery of stone tools important?
Listen to part of a lecture in an art history class. The professor has been discussing illustrated books.
I want to take a look at one particular book to give you an idea about what was involved in publishing illustrated books in the 1800s. The book's called The Birds of America, and the illustrator was John James Audubon. So, The Birds of America, 4 volumes which contained illustrations of nearly every bird in the United States. Over 400 birds, all hand-colored, all painted life-sized, the larger birds printed on the largest printing paper available at that time. This required a lot of dedication, and Audubon is best remembered as an incredibly meticulous, accurate artist, a very accomplished illustrator of the natural world. And while there were other artists working on similar projects at the same time, Audubon's book remains the most well-known and successful of its kind. But let's talk a bit about Audubon himself first. First of all, Audubon was not a traditional painter, and by this I mean that he didn't work in oils. He preferred to use watercolor and pastel crayons, and he worked on paper instead of on canvas. The thing is, Audubon considered the illustrations in his book, not the original watercolors, to be the finished product. His watercolors were merely preparatory studies, most of which were painted while he was observing birds in the wild. These watercolors were then sent to his printer, who created the final prints for the book. And Audubon was so concerned with accuracy that he often scribbled notes to the printer around the edges of these original watercolors. In fact, you might question whether producing a work of art was even Audubon's goal. Now, when I look at an Audubon illustration, I see a work of art. But it may make more sense to consider Audubon first and foremost as a naturalist, as a scientist. See, the early 19th century, when Audubon was painting, was a time of major scientific inquiry, and an essential way of spreading scientific knowledge was through illustrated books.
So, what did Audubon consider himself, an artist or a scientist?
I'm not sure the distinction between the two was all that clear in the 1800s. I think we can accurately state that the driving force in his art was getting the science right. And this was perhaps a point that critics of his artwork at the time just didn't appreciate. Audubon also studied birds in ways that didn't directly inform his art. You know what bird banding is, right? A bird has a band attached to its foot so we can learn about things like migration patterns. Well, the first recorded instance of anyone doing that, it was Audubon. Another example. A common belief at the time was that vultures use their sense of smell to find food. Audubon didn't believe that, so he tested it. He put a large painting of a dead sheep in a field, and sure enough, vultures found it and started pecking at it. Now, Audubon's work was very accurate, and we know this because we can compare his illustrations to the birds around us. But sometimes it's not possible to check. There are actually several birds in his book that no one's ever seen. These are sometimes called Audubon's mystery birds because, even though he drew them, there's no evidence that they exist in the wild. For someone who's respected as a naturalist, isn't it strange to think that he drew some birds that don't appear to be real? For example, there's an illustration that appears to be a type of warbler, a small bird. It has a white ring around its eyes and white bars on its wings. No one's ever seen a warbler like this, so some people wonder if Audubon maybe forgot certain details about this bird when he painted it, or that he copied another artist's work. But considering that Audubon was such a meticulous artist, well, there might be a better answer. Hybridization is something that's well known in birds, and it definitely explains a rather unique-looking duck Audubon painted. He himself suggested that maybe it wasn't an unknown species, but a hybrid born from 2 different species. Since then, this particular crossing of species has actually been recorded, both in the wild and in captivity. So it turns out that Audubon was right, and this duck actually was a hybrid.
What does the professor mainly discuss? According to the professor, what were 2 steps Audubon took in producing his illustrations? What does the professor imply about critics of Audubon's art? Why does the professor discuss Audubon's experiments with vultures and banding birds? What are Audubon's mystery birds? What does the professor believe is the most likely explanation for Audubon's warbler illustration?
Listen to a conversation between a student and the director of the Student Activities Center.
Hello, Jack. Is everything set for the trip this Saturday?
Everything's ready. 15 people have signed up. Our train gets into New York City at noon, which leaves plenty of time to get downtown to the art gallery for the reception.
It's great you could organize this. What an honor having a painting by one of our students in that exhibit.
Yeah, my roommate's so modest. If we weren't such good friends, I'd have never realized his work was being exhibited. So, since I was going anyway, for the opening and all, I figured I might as well make a student event out of it. Working here at the Student Activities Center has made me realize how popular our activities are. I figured there'd be interest in it.
Well, you've done a super job organizing everything. Those posters look great, and they went up in no time.
Thanks, and I'm glad you could approve the funding for us.
My pleasure. By the way, how are you getting to the gallery from the train station?
Well, there are buses that run downtown.
Right. You grew up in New York City, didn't you?
Yeah, but the bus? Well, that's kind of what I wanted to talk to you about.
Yes?
I realized it's last minute, but, well, the weather for Saturday is supposed to be really nice, sunny, warm. It'd be a great opportunity to walk the High Line.
The what?
Haven't you? Oh, I guess not everyone's heard of it. It's this amazing, it's like this park in the sky.
A park in the sky?
Yeah. Well, see, there was this old train line. You know, one of those elevated lines, the kind that run high above the streets?
Okay.
Well, this one was used for freight, not passengers.
Uh-huh.
But when it got cheaper to move freight by trucks, they stopped using it. It was abandoned for a long time. And then, a few years back, the city agreed to turn the tracks and surrounding area into a park. It's not very wide, but it's over a mile long. And it goes from the train station all the way downtown near the gallery. I've walked it before. It's really cool. There's grass and flowers everywhere. And since you're high up, you get these great views of the city.
Sounds wonderful, but have you considered not everybody might be interested in walking that far? They might prefer the bus.
Couldn't we just split up? Have some of us walk and the others take the bus?
But remember, Jack, the poster advertises you as the tour leader. Not everybody's as adventurous about getting around the city. You'd need to find someone to accompany people on the bus. Then you'd take the walkers.
Yeah, but who? The trip's in 2 days.
Well, I did my graduate work in New York. Of course, it was a while ago, but I still know how to get around the city.
Yeah?
And I'd love to see that exhibit.
You'd go? Oh, that'd be great.
Why does the student go to see the woman? What point does the student make about his job in the Student Activities Center? What 2 points does the student make about the history of the High Line? Why does the woman mention the information in the poster? Listen again to part of the conversation, then answer the question.
The trip's in 2 days.
Well, I did my graduate work in New York. Of course, it was a while ago, but I still know how to get around the city.
What does the woman imply when she says this?
Well, I did my graduate work in New York. Of course, it was a while ago, but I still know how to get around the city.
Listen to part of a discussion in a history of science class. The class is discussing the heliocentric theory.
What I find really difficult to understand is why the heliocentric theory, why it wasn't believed by everybody right away.
Well, one thing that's hard to do is to sort of see things from the perspective of someone who's hearing that theory for the first time. I mean, today we tend to assume that the moment the heliocentric theory was laid out, the idea that the sun, not the earth, was the center of the solar system, that, you'd have to be in denial not to accept it. But it really wasn't that easy.
But the idea that the Earth wasn't the center of the universe, that had been tossed around for like centuries, right? I mean, lots of people had the idea.
Yes, that's true, going all the way back to the ancient Greeks. But in Europe, when Galileo championed it in the 17th century, due in part to his discoveries using a telescope, there still was some major resistance to it.
But I still don't understand why. I mean, isn't it obvious?
Well, despite Galileo's ingenious arguments in support of the heliocentric theory, there was still a lot of reasons why people of that period couldn't buy into it. Remember, we're talking about 400 years ago, so let's think about a few of those reasons, okay? So, first of all, they could work out that if the Earth was going around the sun, then it had to be traveling at many thousands of kilometers per hour. And that was just beyond anything anyone could understand. They could understand riding a horse or walking. Maybe they could get up to 32 kilometers per hour, but tens of thousands of kilometers per hour? That was just crazy. So, to many people, whatever's going on, it couldn't be that.
So people didn't believe the heliocentric theory because it was so hard to believe?
Exactly. But there were more scientific kinds of reactions as well. 'Cause, look, if you've ever been on a carousel or you're on a ride at an amusement park and you're on something that is going round and round and round, two things, all right? One, you know you're moving, there's no doubt. And the other thing is, you know that unless you hold on tight, you're going to go flying out because of centrifugal force, right?
So, if I understand you, for the average person 400 years ago, there was no evidence that we were moving at high speed, right? Since everything was securely on the ground and no one was flying off into space?
Yes, and in particular, and this was one specific difficulty for people in the period, even if they thought that there was some sort of force that maybe kept you and me and buildings and things on the surface of the Earth, their theory about the nature of the atmosphere was that nothing was holding it down. So, if you can understand that way of thinking, then clearly, if the Earth was moving at a great speed, we should have lost all our atmosphere a long time ago. It would be like trailing away behind us. And so, I want to try a little thought experiment, because I think that what we'll find is that some of us have ideas about motion that actually fit with anti-heliocentrism.
Anti-heliocentrism? No way. This is the 21st century.
Well, then let's see. So, picture the following. You're at the equator, moving at 1,600 kilometers per hour, okay? And you drop something small and light, like a matchstick, for example. Where's it going to land?
That's easy. It'll be long gone. The matchstick is so light, it'll fly right out of my hand and end up way behind me somewhere.
Actually, that matchstick you dropped, it'll land right at your feet.
What?
Well, let's think about it. You forgot to consider that the Earth's rotating at 1,600 kilometers per hour at the equator. And you, me, the air, and that matchstick, we're all moving together at the same speed, even though it doesn't seem or look or feel like we're moving. So, class, clearly, even today, we actually have some inclination to think that if the Earth were moving around at a great speed, we ought to see signs of it. Perhaps now you're less inclined to dismiss those who once found heliocentrism so hard to believe. Okay, let's move on.
What is the professor's main purpose in the discussion? What do the examples of riding a horse and walking represent? What point does the professor make when he discusses a ride at an amusement park? According to the professor, 400 years ago, what was believed to be true about Earth's atmosphere? Why does the professor talk about dropping a matchstick? Listen again to part of the discussion, then answer the question.
So people didn't believe the heliocentric theory because it was so hard to believe?
Exactly. But there were more scientific kinds of reactions as well.
What does the professor mean when he says this?
But there were more scientific kinds of reactions as well.